All right. AP Calculus lesson 3-6, Analytic Analysis, F increasing, F decreasing, F critical value. Today's date is Tuesday, October 20th, 2020. Our objective today is to, Andrea. There it is. All right. So 5 easy steps. These are the steps you're going to be doing every single time when you're doing the F prime test and the F double prime test. The F double prime test is a little bit different. Let's talk about these steps. So first, you want to draw your x-axis. Draw the x-axis. If you're oversimplifying things, draw a line. And Chris, do you mind taking down your hood so I can see your ears, please? Number 2, find CVs. Okay, just have your ears showing them. If Miss Sasson comes in, I don't want to get in trouble. I'm sorry. Step number 2, find CVs. I should say FCVs, right? Function CVs. Give me the definition of critical values. Stefan, go. Deanie, there it is. Thank you. Step number 3, you need to test some points and test smart points. So test points, plug in the easiest possible numbers. So easy numbers are like 0 or 1 or maybe -1. You're going to be testing those points on the sides, of the CVs. I'll just say CV for now, of CV. And I'll also say this, when you test your points, what I mean by testing the points is that you're plugging it back into whatever F prime is. So I'll say plug into F prime. Why did I do 5 steps this year? Last year I said there were 4 steps. I'm trying to remember what the change was this year. I don't have it written down, so I'm going to go with 4 steps until I can remember what our 5th step is. Step 4 should be our conclusion. That's interesting. Try to remember. Don't know. Okay, let's do example number 1. Find the critical values where the function is increasing and where the function is decreasing. So we're finding 3 things, and I have them listed right there. CV, increasing, decreasing. Where are those intervals happening? Or these are going to be x values for CVs. So step number 1, everyone draw your x-axis. Go. AKA draw a line. There's our line. We can say this is our x-axis. X. And then we need to find some CVs. So let's work over here. This is going to be my area to find CVs. I have to find F prime. I'm only given F. So what is F prime, Chris? Yep, F prime. If F is -3/2 x squared, take the derivative and you get. So the 2 comes down in front, right? So I'm going to have something that looks like -2. I can write it down here. I don't know what I'm doing. So it's going to be -2. That was the 2 that was brought down in front. I still have the 3/2. It is x to the power of what now, Chris? To the power of 1. Yeah, just x. And simplify, Chris, this turns into just -3x, yeah. -3x. Okay, so the derivative is -3x. That's the derivative. Fiona, what are we going to do with that to find CVs? Zero for close. 0 for the F prime of x. We're going to set the derivative equal to 0. This is the derivative. We're going to say -3x equals 0, which is the equivalent of saying F prime of x is now 0. So we're going to say 0 is equal to that -3x. Set our F prime equal to 0. Or if it's a DNE, that means I'm setting the denominator equal to 0. I just don't have any denominator here. So set numerator and denominator to 0, and then solve. Fiona, what is x? Solve for x. 0. Yep. So we only have one CV, it's at 0. Let's go ahead and write down our CVs on our number line right there. Boom, at 0. That's a CV. We'll label it CV. And then I'm going to do step number 3. I'm going to test some points on the side of the CV. So what's a good point to test on the left and the right, Andrea? Yeah, let's test out 1 and let's test out -1. I'm not labeling those as CVs. Those are just going to be my test points here. And I'm plugging those into f prime. So Andrea, help us out. F prime is right there, -3x. When I plug in 1, do I get a positive or a negative? Get a negative. So everyone over on this side, write down, this is a negative. And Andrea, when I plug in -1 into -3x, I get a positive or a negative? Positive. Okay. And I guess I should have really put the positive and negative on the bottom. The top should be reserved for the spots of what is happening. So this is a negative over here. This is a positive over here. So Teflon on you now. Andrea has told us f prime is positive over here. F prime is greater than 0 over on the left-hand side. That's the definition of f increasing, yeah. F increasing. And on the right, Teflon, that's f decreasing. Chris, on you. List these all out. Give me the intervals and x coordinates. FCV is at 0. At x is equal to 0. Yep. What are the intervals that f is increasing? Everything to the left of 0, right? Everything this direction. So how do I say everything left of 0? X is less than 0. Perfect. And how do I say everything bigger than 0 for decreasing? X is greater than 0. Done. Fiona, can you translate these into interval notation instead of inequality notation, just in case we need that? How do I? 0 and perfect. All right. There's the 2 different ways to answer that one. Let's move on to example number 2. Find the function's critical values and where the function is increasing and decreasing again. Thank you, QuickTime Player. You can go away. What do I do first? First step. Andrea, tell us. Draw the x-axis. Let's do it. Shrink. There it is. I guess so. I don't need to draw it so big like last time. There is our x-axis. Teflon, what are we doing next? Find our FCVs. All right. And what's the definition of a critical value again, Teflon? Yeah, exactly. And those 2 definitions does not exist means I'm setting the denominator equal to 0. There is no denominator for this question. So I'm really just setting the numerator or just setting this entire problem equal to 0 after I find f prime. So Teflon, can you do f prime for us also? And then I'll move on to Chris. F prime of x. Say again? Yep. Keep going, yep. +4. There it is. Thank you. All right, Chris. Teflon has the derivative for you. She also told you that the definition of the derivative is f prime is equal to 0 DNE. How are you going to use that definition to find your CVs? It's the same process that Fiona did last time too. If you want to take a look up here. She set the derivative, -3x equal to 0. Okay, tell me what to write. Tell me what to write verbatim. Okay, solve. You want to add x squared to both sides? That's probably the easiest way to go.
Yeah.
Okay, add x squared to both sides. Boom. Boom. All right, now what?
Right.
Divide by what?
That's good. Oh, okay.
No, I don't think you want to divide. You want to try to undo the square right now. What's the way that we undo squares?
Square root.
Yep, square root both sides, square root, and therefore, Chris, x is equal to, close, that's half of it. Whenever you square root, you always have to do plus or minus. Yep. All right, thank you, Chris. All right, Fiona, you're going to help us with our number line. I will go ahead and help you label the -2 and +2. I will also tell you that those are CVs. I'll help you label those. What do I do from here, Fiona? Which values do you want? -3. All right. And then you need to plug it into the derivative that Teflon found. Teflon said you're going to be plugging those into f prime is equal to -x squared plus 4. So Fiona, you can start with whichever number you'd like. You can do -3, 0, or 3. Okay. Into f prime. Yeah, so it's positive or negative? Positive. Keep going. Okay, what about the next number? Which one are you plugging in? 3. Okay, yeah. So try again. So if you plug in 3, this is going to be 3 squared, which is 9. So order of operations, please excuse my dear Aunt Sally. There's no parentheses. Next order, exponent, then m for multiply. So square and then multiply by the negative. So 3 squared is 9. Then you get -9, then -9 plus 4. Yep, so it's negative. Yeah, exactly. A negative. And also do it for -3 too, please. Say it louder. Not quite. Try again. There it is. Yeah, negative as well. And then Fiona, almost done. What is this then? When this f prime is negative, that is the definition of f decreasing. Next one is, and then there it is. Thank you. Andrea, can you give us the x values and intervals here? X is equal to plus or minus 2, yeah. F is increasing. Say it again. So be careful. It should always be between critical values, right? Between this critical value and this critical value as it's increasing. Two. Should these be brackets or parentheses? Brackets would mean it's equal to, but add a CV that's equal to 0, so it's not actually a positive number. Yeah. So parentheses. How would you say that in inequality notation, Andrea? Perfect. Go ahead and do decreasing as well, please. So it's decreasing everything to the left of that critical value, and it's decreasing everything to the right of that one. So let's just talk about the first one. How do I say left of -2? Yeah, so at negative infinity to negative 2. And then you can do this little or symbol. Then the next interval, everything to the right of 2 is also decreasing. How do I say that? 2 to infinity. Perfect. How do I say that with inequality notation? 2, and then that little or symbol, and then everything to the right of 2. There it is. And there's our final answer for example number 2. We have one more example on the back. How well are you following me up to this point? Fist of 5. Fist of 5. How lost are you? 3, 4, 3, 3. Is there a question that we can ask to clarify? Question? No? All right. Well, let's just try another one, I guess. Yep, same thing, same question. CVs, increasing, decreasing. All right, first up, Teflon, go. X-axis, shoink. There it is. I can make it a little bit longer. I think this is going to be a bigger problem. So we have arrows there, arrows there. This is our X. Keep going, Teflon. Next step. Find FCVs. What's the definition of FCV, Chris? F prime, yeah. Perfect. Okay, so that means we need to find F prime. What is F prime, Chris? You're close, yes. I'm thinking you see the 3 cancels out with the 3, right? Yeah. So 3 and 3, that cancels to 1, and then it's going to be 1x to the power of 2. Yeah, so x squared. Keep going. 4x. Not quite, yeah. So the plus 4, that's a constant. The derivative of a constant is 0. There it is, yeah. So you have the derivative for us. Let's see, yeah. Fiona, what do we do now? All right, and then what do we do? Okay. You could, let's do it. Negative 4x is equal to x squared. Would you like some help? Back on this step, there's something that we can do. I'll wait for a volunteer to find what we should do. You do, yeah. So how do you do that, Teflon? Factor out the x and you're left with x plus 4. There you go. And then we're going to use the zero product property. If something times something is equal to 0, that something is 0, or the other something is 0. So set them both equal to 0 to cover all of your bases, right? So we're going to set this x equal to 0, and we're going to also set that x plus 4 equal to 0. So there's 2 equations that pop out of this. There's x equals 0, and there's x plus 4 equals 0. Oop, that equals 2 sign could be better. And then back to Fiona. One of x is 0, the other x is -4. All right, so let me graph those for us. We have -4 to the left. I should do these in green. I think that's my color of choice for these previous problems, right? CVs are green. Oh, not really. I've been hopping all around. So I have -4. Then I have 0. I'll label those. Those are our CVs. CVs. Andrea, what are you from here? Cool. Which ones are you going to test? Yeah, those are the numbers I would have chosen as well. All right. And Andrea, help us out. So you're plugging into Chris's derivative. First one is going, this one right here, the -5 is positive. Okay, so positive. It's -1. I think that's, yeah, negative. Just verifying the math out loud. So it's -1 squared is 1, -4, that's -3. Perfect. Keep going. And positive. Give me the definitions of what you just found, Andrea. What is? Increasing. Did you need to drink some water? Are you okay? Okay. I feel bad for making you speak so much. Okay. And Teflon. Go ahead and list our CVs increasing, decreasing. What are these things? -4 and 0. Yep. -5 to 1 is close, but remember, -5 was just a test point. -6 is also increasing. -7 is increasing. -100 is increasing. It always cuts off at the CVs. The CVs are the point at which it goes to 0 and then maybe changes sign. In this case, it does change sign. So yeah, so -4. That's one of them. And the other interval, there's CV here, and then everything to the right of that is increasing. 0 to infinity. There it is. Yeah, nice. Can you do that in inequality notation? How do you say everything to the left of 4, or -4, sorry? X is less than -4, or, and then how do I say everything to the right of 0? Yeah, done. Okay, that's inequality notation. And then we'll give it to Chris too, so we can get everyone in again. F decreasing, what are the intervals for decreasing, Chris? So it's happening right here in between this CV and that CV. So -4 to 0. Should we have parentheses or square brackets? Well, what happens at that CV? What is the value of f prime? Is f prime positive, negative, or 0? The definition of CV is f prime 0. And since we're looking for decreasing, that's the definition of f decreasing is speed sheet. F prime decreasing, or sorry, f decreasing is f prime less than 0. So this is equal to 0, not less than 0. So it can't be equal to -4. So you have to do parentheses instead of square bracket. So from -4 to 0, and how do I say that with inequality notation? X is less than 0, and X is also greater than -4. Yeah. All right. So that is kind of it, but I do want to talk about some tricks with E because it's going to be on the homework. If I have e to the power of x, let's see what happens in terms of when this function is positive, when this function is negative, because it'll save you a lot of time. So I'll graph this at the very end. If I graph it right now, it'll give it away. What is f of 5? If I plug in 5, it's e to the power of 5, right? So f of 5 is e to the power of 5. Is e to the power of 5 positive or negative? Well, e is about 2.7, right? So think of it as about 3. 3 to the power of 5, is that positive or negative? Everyone shout out. Yeah, it's positive. So this is positive. Okay. Now, what do you think is going to happen when I plug in -10? Is that going to be a negative or a positive? It might be a negative, right? So I'll come over here and say that's a positive if you don't like the greater than 0 notation. When I plug in -10, I get e to the -10. Ooh, but negative powers, I can turn that into a fraction. I can flip it, right? So that's really 1 over e to the positive 10 And you, again, just think of e as a number like 3. So this is 1 over 3 to the power of 10. Is that positive or negative? It's positive still. Yeah, so this is still greater than 0. And again, if you don't like the greater than 0 notation, you can do a little plus sign. That's still positive. And the trick that I'm trying to show you here is no matter what value you plug into x, this is always going to be positive. So e to the x can never be negative. Not only can it not be negative, it also can't be a certain number. It can never be 0. Which means it can never be a CV. If you take the derivative and you get some sort of e to the x, that will never be a CV. You can go ahead and eliminate it. Like if you have a problem that looks like this, say I took the derivative, right? I did all the hard work, and I say f prime of x is equal to e to the power of x times x plus 1 or something like that. If I'm trying to say, okay, use the 0 product property and say, okay, I'm trying to find CVs, right? The same process that we did above. I'll say 0 is equal to e to the power of x times x plus 1. I'm just trying to find the CVs. And I say, okay, well, that's going to do 2 different equations. That's going to be e to the power of x is equal to 0 and x plus 1 is equal to 0. This left equation, you can't solve it. E to the power of x never can be 0. You can, if you want to save some steps, you can just go ahead and eliminate that right from the beginning when you plug in 0. That'll never be equal to 0. Not only that, but when you're trying to find the signs of the interval, that is always going to be a positive number. So when you're trying to plug in, you're going to say it's a positive times whatever plugging into this thing is. You can kind of ignore it. I will point out this one thing too, which is if I have a number in front of it, like a times e to the power of x, typically like -2 e to the power of x or 3 e to the x, whatever the sign of a is, that's going to be the sign of everything. For example, if I have -2 e to the power of x, it will always be negative because I'm multiplying it by -2, since e to the x is always positive. So a to the power, a e to the x will always be the sign of a, whatever a is. So if a is a negative, then that whole interval for e to the x is also going to be negative. Okay, that's the end of the lesson. Can you guys give me the fist of 5 for our objective today? How can you find where the function is increasing, decreasing, and has critical values without a graph, just using this process? I got 4, 4, and 3. All right, thanks.